Hello everyone and welcome to today's lecture on regression. In educational research, regression is one of the most powerful tools we use to understand relationships between variables, especially when we want to make predictions. Let's start with the definition. Regression is a statistical method that helps us understand how the value of one variable changes in relation to another. Most commonly, we use linear regression, which models a straight-line relationship between two continuous variables. In this model, we refer to the predictor variable as the independent variable and the outcome as the dependent variable. So why do we use regression in education? Let's take an example from early childhood. Suppose we want to know whether the number of picture books in the home predicts a child's vocabulary size by the time they enter kindergarten. We could collect data from 100 families, count the number of picture books in each home, and administer a vocabulary assessment to each child. Using regression, we can determine whether there is a statistically significant relationship between the number of books and the child's vocabulary score. And even better, we can quantify how much vocabulary tends to increase for each additional book in the home. Now let's jump to a middle school example. Imagine we want to examine whether students' math homework completion rates predict their performance on standardized math assessments. In this case, we could treat homework completion rate as the independent variable and test score as the dependent variable. The regression equation would help us estimate how much of a score increase we might expect as homework completion improves. When we perform a regression, we get several important outputs. First, the regression coefficient, often represented as lowercase b, tells us how much the dependent variable changes for each 1 unit change in the independent variable. Second, the p-value tells us whether this relationship is statistically significant. If the p-value is below a threshold such as 0.05, we conclude that the relationship is unlikely to be due to random chance. Third, we look at the r-squared value, which tells us how much of the variance in the dependent variable can be explained by the model. For example, an r-squared of 0.60 means that 60% of the variability in test scores can be explained by homework completion. You'll also hear about residuals in regression. Residuals are the differences between the actual observed outcomes and the outcomes predicted by the model. If your model predicts that a student should get a score of 80 based on their homework completion rate, but they actually scored 85, the residual is +5. By analyzing residuals, we can learn a lot about how well our model fits the data. Now let's look at an example from high school. Suppose a researcher is studying whether high school students' GPA predicts their first-year college GPA. This kind of analysis is extremely common in educational policy and accountability research. Admissions officers, school counselors, and policymakers rely on this type of information to make data-driven decisions. Finally, let me emphasize a key point. Correlation is not causation. Just because two variables are related in a regression model does not mean one causes the other. Other variables called confounders might be influencing the relationship. In our early childhood example, maybe parents who have more books at home also spend more time talking with their children. It's important to think critically and contextually about what the model is really telling us. Regression gives us a powerful lens to see patterns in data and to make informed predictions, but we must always interpret results carefully and within context. Thank you very much for watching this video. See you next time.